degrees and 30 minutes. And your goal is to use the half angle formula so that you can find an angle in the unit circle that would kind of correspond to it and then evaluate it. And the tangent, Joe, yeah, so Joe is saying that the angle that you're using for you is 135 degrees, because if you cut that in half, that gives you then the 67 degrees 30 minutes, which is the same thing as 67.5. So the angle you want to use is 135 degrees for all three of them, because cutting that in half gives you the half angle of that then. What's the formula that you use, Joe? I just want to make sure you're using.
It was 1 minus cosine over sine.
Okay. So I would say when you're plugging into one of the formulas for tangent, do not use the one with the square root in it. So use one of the simplified versions, even, he said over the sine, not over 2. So either use 1 minus the cosine over the sine, or the sine over 1 plus the cosine, either one of those. But definitely go to one of those simplified versions so you're not having the square root in the problem. And then 135 degrees is in the second quadrant. So Joe, if we're evaluating this, the cosine of 135 degrees is?
Negative square root of 2 over 2.
Right. So to use the formula, take the location of the angle was located in the third quadrant, and then we're taking the cosine of that angle of 135 degrees, which is negative square root of 2 over 2. And then on the bottom we have the sine of 135, which is
Square root of 2 over 2.
square root of 2 over 2. Yep. Any questions on that so far? It would work the same way if you use the sine over 1 plus the cosine, so it will end up reducing the same way. But you do plug in the values at least in the same way. So the next thing then would be algebra, because we've done the trig, so now it goes back to the algebra, and we need to start simplifying this. So Brad, one thing that we can do to simplify it.
You can make it 2 minus, or 2 plus square root of 2.
Yeah, so this here becomes a plus because we have a minus negative, getting a common denominator with the 2. So we would have 2 minus the square root of 2 over 2, and then that's over the square root of 2 over 2. So the minus negative becomes a plus, get a common denominator. What else can we do, Kristen? Yeah, so take the denominator and flip it, so that would be 2 over the square root of 2. Lots of square roots of 2's in here. These cancel, so that leaves us with 2 plus, yeah, thanks, 2 plus the square root of 2. Diagonally reduce those, and then on the bottom we have the square root of 2. What else do we have to do to simplify it? Joe?
Would we multiply the top by square root of 2?
So the last thing here, there's still a square root in the denominator, and that square root isn't allowed to be there. So you're multiplying the top by the square root of 2, bottom by the square root of 2. So I have 2 times the square root of 2. And then the square root of 2 times the square root of 2 is 2. On the bottom, the square root of 2 and the square root of 2 is also 2. Anybody like 2's? Like have a good, your favorite number is 2? No? So the last thing to simplify this, there's one final step.
We divide all the 2's by 2 except under the square root.
Exactly. So all of the outside numbers get divided by 2, not the number underneath the square root. So we have the square root of 2, and then plus 1. Did you see where you made a mistake?
Yeah, I didn't know how I was taking out like the square root of 2 from the bottom, or how to multiply on top. That's what I screwed up.
So, I mean, it really is an involved problem algebraically. There's a lot of steps, like trigonometry-wise, you're plugging in those 2 terms from the angle. But algebraically, there's a lot of stuff to do with the problem. Joe? 65. equation problem. You have sine of x over 2 plus the cosine equals 0. And I think it said to find all of the solutions. Today you'll have a couple of homework problems that are like this with kind of all the types of equations combined together. But when you're looking at an equation, the first thing you would look for is there a part of the equation that you can replace with a formula or an identity? So I would say like start off with that. So is there something up here that can be replaced with a formula or an identity, Gio?
Sin x over 2 can be replaced with square root of 1 minus cosine.
Right. So we can take out the sine x over 2 and replace it with the formula, which is 1 minus cosine x over 2. And then we still have the cosine, and it's equal to 0. This one is just a cosine. You can do anything with it, so there's no identity or formula. I mean, we could make up one over the secant, but then you put another fraction in the problem, so we won't do that. So now, thinking about when you're solving square roots. So when we solved equations involving radicals, you did it last year, we did it at the beginning of this year. What is the rule that you have to go by in order to square both sides? Because that's what our goal is. We're going to be squaring both sides, but you have to do something first in order for you to square both sides of the equation. Kristen? You have to isolate the radical, and I think that's the part that some people are forgetting. So you can't just like put a square around that quantity or just square both pieces. You have to have the radical isolated. So the cosine has to be taken to the other side. And then the radical needs to be by itself. And that goes along with any kind of radical that would be in the problem. So radical needs to be isolated in order for you to square the radical. So if we square the left, whether I'm squaring a positive or a negative, it just becomes a positive value. And the radical cancels out. On the right side, this is also a negative, but when we square it, it becomes a positive. So we have 1 minus cosine squared over 2, and then that's equal to the cosine squared. Do you know what we would do next?
Would you change the cosine squared to?
Let's talk about the left side. Yeah, let's get rid of that denominator. So we still have a fraction. If we can, we'll get that out of the problem. So the 2's go away. We have 1 minus cosine. And then 2 cosine squared. So they're all cosines, which is good. Joe, what would you do to get this to look like something we can work with then? Yeah, and then after you move them over, what would be the process, Joe, that you would use? Excellent, yeah. So now it's factorable. So if we can get everything to be like in a linear format, I know the terms aren't linear, but if everything would be in one line, instead of having a rational in there, or the radical, that would be our end goal. So now you can factor this using the AC grouping, and then solve each of those pieces individually. Questions with this problem? 69 was the last one of the homework.
57.
So,
We got like through half of it.
which part of 57? The cosine? Okay. So 57 says the tangent is equal to negative 8 over 5. Is that what it says? Or 5 over 8? 8 over 5. And then the angle is between 3 pi over 2 and 2 pi. I think that's what it says. So angle should be in the 4th quadrant. Tangent is the opposite over the adjacent, so opposite and adjacent. And then if you square both of these, we have 64 and 25, so that is 89. And you cannot take the square root of either of those, or of 89. There's nothing that breaks down into it. So then she said, let's look at the cosine. And D, the formula for cosine is?
Square root of 1 plus cosine over 2.
Right. So this is the formula for cosine. We have the plus or minus square root of 1 plus cosine u over 2. So if I plug in the information, the cosine is the adjacent and the hypotenuse, so I would have 5 over the square root of 89, and then all of that's over 2. So now, we need to simplify this. There are different ways to simplify it. So the top is definitely what we need to focus on. You can choose to rationalize this fraction first, or you can get a common denominator and then rationalize it. It's up to you. Did you start doing one way or the other? Just kind of take
I
it
would
away.
like to rationalize first.
Okay, so if we rationalize it first, that means I have 5 square roots of 89 over 89, and then that's all still over 2. So this is a big 1 here. The 1 is by itself. And then we have plus 5 square roots of 89 over 89, because I'm multiplying top and bottom of just this fraction to rationalize it. Neil, what else could we do then?
You could set the 1 to 89 over 89.
Right, so the 1 could become 89 over 89, and then we can add the top. So I have 89 plus 5 square roots of 89. Now I have a common denominator of 89, and then all of that's over 2. Let's see, anything else? Yeah, so instead of dividing by 2, we can multiply by 1/2. So we've got 89, 5 square root of 89, and let's see, 89 times 2 is perfect, 178. So that's actually, you don't have to simplify it any further. You can keep everything in here underneath the radical. But there's, the last thing is we have to decide if it's a plus or a minus. So everything under the radical is as simplified as it can go. But you need to know, like, why is it a plus or why is it a minus? And it does switch for sine, cosine, and tangent. So they're not all pluses, they're not all minuses. And that depends on where the angle is located, and it's the half angle. So the location of the half angle, because that's what we're trying to calculate. So the angle that we're given is 3 pi over 2 to 2 pi. Where would the half angle be located? What would the restrictions be for the half angle? Kristen?
3 pi over 4
So if you essentially take your restriction and multiply it by 1/2, because I want the half angle. So those restrictions really need to be cut in half. She said that would be then 3 pi over 4. My angle is now being cut in half. I'm multiplying it by 1/2. 2 pi. So Abigail, 3 pi over 2 to pi is what quadrant?
That would be a 4.
It was in the fourth question. So think, where's 3 pi over 4? What quadrant?
third.
How about the second? So 3 pi over 4 is in the second quadrant, 2 pi, which stops the second quadrant. And then the last thing that you need to ask yourself, now that I know where it's located, we're dealing with sine or cosine. So if I'm finding the cosine, D in the second quadrant is cosine, positive or negative? Negative. If I was finding the sine, it's positive. So the sine would be a positive value because sine is positive in the second quadrant, but cosine is the negative. So we want the negative of the radical because the half angle is in the second quadrant. So don't just automatically look at the current angle you're given. That restriction just applies to the formula as you're following through it. So the plus or minus on the outside goes with the location of the half angle. Questions? So I think this is more tedious work. We'll have to think about a lot of algebra to do. Questions that you have? 61. I'm gonna do a couple problems like 61. So it's one of the, like, you have to match it with the formula. So I'm gonna this review worksheet is one of the 3 chapter 5 review worksheets, and it's titled Trig Identities. So the first 6 problems are very similar to 61 of your homework and 63 of your homework. So the directions want you to write the following as a function of a single angle. So essentially, you have an expanded form here. Your goal is to look at the expanded form, match it with one of the formulas to condense it. So are we talking about the sine of a half angle? Are we talking about the cosine of a double angle? Are we talking about the sum and difference or sum or difference of sine, cosine, tangent? So if you look at the first one, we have 2 sine 8x cosine 8x. What formula does that look like? Joe?
Sine
Sine of what?
4x,
Before you tell me that, sine of what?
2x.
So it looks like the sine of a double angle. That's the form that it's in. So this is the double angle formula for sine. The angle in the problem is 8x. That angle replaces the x in your double angle formula because I'm doubling whatever angle they're giving us in the problem. So I have the sine of a double angle, well the angle is 8x. So if I simplify this, I get the sine of 16x. So the angle has to be doubled, the angle they're giving us is 8x. That's it, sine 16x. So the next one, we have the square root of 1 minus cosine 4x over 2. So what formula does that look like? Abigail?
Sine u over 2.
So that looks like the sine of u over 2, which is the sine of the half angle. So take the angle they're giving you and plug that in for u. And then that becomes the sine of 2x. Again, that's it. So for the other 4, they all have actual angle values in them. They're all degrees. So then you would have an actual number after the sine. So maybe like the sine of 80 or the sine of 60 or the sine of 40. If the angle is something on the unit circle, then I do want you to continue simplifying it. So if you end up with something that says the sine of 45 degrees after you've applied it to one of the formulas, then simplify that to be the square root of 2 over 2. So if you can take the sine, cosine, or tangent of an angle that you have memorized in the unit circle, then actually evaluate that angle. Questions? So Joe, that was very similar to that question I got. So if you look underneath, the second set of questions deal with 2 facts up here. The one fact says the sine of x is equal to 7 over 25, and it's in the second quadrant. And the cosine of y is equal to 12 over 13, and y is in the fourth quadrant. So, create some triangles. These 2 triangles will be used for all of the problems underneath. Andrew, what 2 sides are sine?
Opposite.
Right, opposite and hypotenuse. So this is my x triangle. The opposite is 7, the hypotenuse is 25. Does anybody know what the adjacent side would be? 24. Positive or negative? Negative, yeah. So it's a negative 24. And then the other one, we have cosine. So sine was opposite, cosine is adjacent on hypotenuse, and Isaac, the vertical side here would be negative 5. Perfect. Alright, so there was a lot of confusion about the bottom problems in first period. The sine does not distribute through and become sine x plus sine y. This is a formula. Which formula is this for? Kristen? The sum and difference formula for sine. So you need to expand it into the sum and difference formula for sine, which says take the sine of the first angle times the cosine of the second angle. You're adding that to the sine of the second angle times the cosine of the first angle. So I'm taking the condensed form and expanding it with the actual formula. Then the triangle and replace the sine of x with whatever it is from the triangle or from the directions. And in this case, the sine was given to us for x as 7 over 25. So now I have 7 over 25. Cosine y. So I need to go to the y triangle, find cosine, which is 12 over 13. And then the sine y is negative 5 over 13. And cosine x is negative 24 over 25. So you should no longer have sine or cosine in the problem because you're using the sine and cosine in the triangle to get a value or a ratio for that. And then you multiply the tops, you multiply the bottoms, common denominator, add them together. So you're going to have a numerical answer. You're not finding the angle, you're finding what the sum would be equal to based off of the two triangles that are given. So those would be the other 5 problems then as well. So look at the identity or the formula, expand the formula, and then plug it in. On the back there are 2 other questions, and those are the verifying identities problems. There's just 2 on there, so you're asked to verify those identities. The other worksheet that is behind that, there are 3 problems on there. You should already have 1, 2, 6, and 7 done. So the 3 problems on there are trig equations. Are there questions? So on Monday, one of those 3 word problems, if you want to do all 3 of them, fine. If you only want to do one of them, great. But you need to have one of them done for Monday. If you turn in all 3, then I'll grade all 3. And at the end of the period, I'll be giving you your partner test for you to look at as well. So Monday, we'll go over a couple of more problems. There is another review worksheet. There's 3 different review worksheets in there. Answer any questions that you have. I think I have a little warm-up to go over with you just to review for the test as well, for Tuesday's test. So if you'd like to work with a partner, you can. You have 16 minutes, although the building time is like 2 minutes slower than Apple time, which to me, Apple time is like what the time is, right? Doesn't the world revolve around Apple time? No? Well, if my iPad, my Mac, and my phone all tell me that the time is 2 minutes slower than what the school time is.
Desktop say.
12:59. And I think the school time is running 2 minutes fast.
That's a desktop, not a laptop.
Oh, I don't know. That doesn't work anymore.
What? What they do, Mac?
Yeah.
Purposely complicated. I don't know, Joe. I don't ask questions.
I would start asking now. Do you actually do work?
Oh, wow.
Tell me when you
See, I
Well, I want to be partners with somebody. Who wants to be my victim? I mean, partner. Show of hands.
you can never do the other class. It already comes from stuff.
I only know one person from the other class.
Yeah.
Yeah, the whole city.
two.